Okay, as I was saying, we're gonna look at constraints today in physics objects. So this is the last real piece of the puzzle. This is basically different ways to attach objects together. So we're gonna start by making a new patch, and we'll have a jit.world. And let's do at floating 1. So we have a floating window, and you probably want to drag your window over to the side. Here, I'll turn on my mouse pose for you guys. Keystrokes. There we go. Okay, so we'll need a toggle, obviously, to turn it on. We're gonna send things to the physics object, to the phys world built inside. So we need a prepend send phys. Prepend send phys, and then we can pass any message that we want to send to the physics world inside of this through this prepend. Really, all we want to do is first off is to change the size of the world box. So let's make a little system for doing that. We can say POC world box scale, I believe, underscore scale. Right, so you never have spaces in your keywords. You have a space after your keyword before your value. Anytime you have a space, Max is going to treat that as a separate argument. So world box scale, and then we're going to have 3 floats for X, Y, and Z. So because we're using a POC, because anybody know why we use a POC instead of a PAC in this case? Yeah, so that it responds to any of those data changes in any of those inlets, it will output its message. Because we're not using that first inlet. Make sure you don't patch to the first inlet in the POC, or else you'll replace the word world box scale with whatever you put in there. All right, so if we turn this on, we're also going to want to be able to see what's going on. We're going to need a JIT GL phys draw. Here, I'll zoom in a little bit more for you guys. There we go. And we're probably going to want to move the camera back. So we're going to want some camera controls. But let's just steal them from the JIT World help file. Open the help file, grab the camera stuff right here, this anim drive, lock, look, and GL camera. Copy that. Paste that in. Now we can see our world box because the camera got pushed back, because camera default was at 0, 0, sitting right at the origin, so everything was so zoomed in you aren't seeing the world box. Now the camera's zoomed back. We can actually use the keys W, A, S, and D to move it back even further, and Q and Z tilts up and down. Right? That's the what is doing this is always keeps it focused on the origin point. That's this lock look parameter. Locks it to look at only one point, and by default that point is the origin. Tripod makes it never change its height, and instead tilt up and down. No, tripod maintains its roll so that it doesn't ever roll like this. Okay. All right, so what were we doing next? Next we want some physics. Oh, we wanted to change the world box scale to 10 instead of, I think by default it's 5. So as soon as you put a value in any of this, it's going to like crush it down to 0, right? But we can just fill those in with 10s, and we should now have a much bigger world box. And we can take our camera here and change the position of this camera to 30 to push us back even further so that we can see everything. Okay, let's do a load mess, right? Which loads a message when you start the patch, and load mess 10. So that way we can put those 10s in the POC world box scale. right off the bat when we first open the patch. So patch all those up. You can patch all three from the load mess to all three of the single output of the load mess to all three of the float number boxes. Okay. Cool. So now we need some fizz bodies, right? So let's see. I think the first thing we're going to look at is a simple point constraint. So this is attaching an object to a point. That point can be somewhere in space, or that point can be somewhere on another object. Let's start with a fizz body. JIT GL fizz body, is it? Fizz dot, no wait, jit.fizz.body, that's what it is. Fizz.body. Right, as soon as we do that, we see our little fizz body fall to the floor. By default, it is a sphere. Oh, if we want to be able to move these things, we're going to want to jit fizz.picker, I think. Yeah, jit.fizz.picker. That allows us to move things around with our mouse. Okay, so by default, this is a sphere. Let's make it into a capsule, just for fun. At shape capsule. Okay, the fizz bodies, they do a reduce hull automatically. They simplify the number of points as much as they can to simplify the physics interaction, because you have a ton of different high poly physics interactions going on at once, then it will start to slow things down, and you usually don't need it. You only usually need something simple to bump into somewhere, and that as long as the model that you have attached to your fizz body is more complex, you won't notice that the collider, the physics body, is more simplified. So that is a capsule. Let's add a JIT GL grid shape at shape capsule. And let's to make this look good, we're going to want to have at lighting enable 1. Just click these out of the list. It's a lot better. At lighting enable 1, at smooth shading 1. Right? And it just is hovering in the air until we attach it to the fizz body, and then they get paired together. Right? So now we can throw this capsule around. We've done this before. We want to actually, you can see that the fizz body is a little bit bigger in my estimation than the grid shape. So to be able to rescale these independently, what we want to do is add the parameter at send scale 0, right? We've seen this before. And then we can resize this to a different scale. At scale 1 period, 1 period 0.5 in the Y scale and 1 in the Z scale. That, in my estimation, that more closely matches the grid shape. See, you can barely see the collider poking out the edge of the grid shape. All right, so the simple point constraint is called a jit.fizz.point-to-point. Point-to-point. And if you open the help file by option clicking on it, it'll open this nice little patch for us, and we can turn this on, and you can see what we're about to do, which is take this capsule and turn it into kind of like a punching bag. Right? It's constrained at one point. They've offset that point to be at the top of the capsule so that it hangs below, right? And then you can move it around however you want. So the offsets that you're looking at in this constraint are this position 1 and the position 2. Those are, let's see, how does it describe those? it describes those as at. It doesn't describe those. Well, anyway, it has to do with where the point is attached on the first body and where the point is attached on the second body. So in this case, if there is no attachment to a second body, there's only the one body that it's attached to, here, this phys body, then the other point, the other position is where that constraint is anchored. So as I move position 2 up, you're moving the entire anchor point up, right? And then position 1, that's where it's anchored in the Z scale. I can make this bigger than 1. I can have it be like 3, and you can see it's kind of like suspended by an invisible rope now, right? So let's try to make this into a proper punching bag in our patch. First thing we can do, let's make the grid shape red at color 1 0 0 1. There we go. We got a red punching bag. We have our point to point. Let's just attach that to the phys body, and there it goes. Right. So right now, you can see the constraint is in the middle of the phys body, so it kind of just rotates about this weird 3-dimensional ball joint. So we want to offset that down. So we need to change our position 1. So we can say POC, just like we did up here with POC world box scale. Float. Actually, let's just grab this. This will be quicker than retyping it. The POC world box scale, float, float, float. Grab this. Change the word world box scale to position 1. Oh, whoops, not into the body, sorry, into the physics point to point. So let's figure out what's a good position 1 for this. Probably, oh, I think we're going to be adjusting the Z value. And there you go, something like 1.5 or so makes it fall down, and anything more than that starts to hang down from an invisible rope. So let's put something in there. Let's see, what did I have before? I have this at 2. Yeah. So let's put that into our phys point to point so that it has that default value at position 1, and I can click it out of the list. Position 1 space 0 period 0 period 2 period. Okay, there we go. And now we want to, what do? We want to have another object. We need the backboard of the punching bag, right? So that's like a cylinder basically that's sitting above the punching bag, but it's like maybe only this thick, right? So we could make one of those. JIT phys body at shape cylinder, and I always spell cylinder wrong. SCYLINDER. Hey, I got it right this time. Phys body at shape cylinder. We want this to actually be locked in place, so let's say at kinematic 1. And look at that. Oh, it's taking up the same point of the bar as the point to point, which is making it go crazy. This is kind of a behavior of the physics engine that's built into Max. It's called the bullet engine. If things are clipping, if physics objects are clipping through each other, if the colliders are clipping, then it just starts to go crazy, and it'll get more and more and more until eventually you'll have so much force that it'll throw your objects out beyond where they're drawn, and they'll just disappear. So we got to adjust this. First of all, we need to rotate our cylinder at rotate XYZ. We need that to rotate around the X axis 90 degrees, 0, 0. So 90, 0, 0. There we go. And then let's scale it at scale. I almost tried scalar. I don't know why. At scale, 1 period, 0.5. No, wait, that's not it. That's the other one. Let's do 2 by 2 with a 0.2 height. So that would be 2 period 0.2 period 2 period. Right? So 2 in the 2 wide, 2 deep, and 0.2 tall. And so now we have like a backboard that this can bounce off of, right? Let's give it a grid shape. You can just duplicate the capsule one over here and change its shape to a cylinder, cylinder. And if you attach it to the fizz body, it'll pick up its scale. Boom. And then let's give it a different color. At color, I don't know, 1.8.1 maybe. Kind of brown, I guess. More like yellow. 0.5. There we go. That's kind of orange. If we wanted this to really look nice, we could attach a material to it. GL material, and attach that to the grid shape, and that will add by default that will add reflectivity to it, so it reflects light and makes it specular, shiny. You can also go inside the material editor and you can load pictures and stuff into it. So you could get a wood grain picture and load this in there. There isn't one by default. There's just this dirt, which kind of looks like wood. But you will have this weird thing with cylinders that it's just all of it can only texture inside triangles, and each one of these is a triangle. So you end up with a lot of tearing at the top of it. Double click on GL material to open the editor. Okay. If you ever want to reset your camera, if your camera gets completely messed up, just all you have to do really is just delete your camera object and then undo, and it'll put it back to where it was. All right, so there we go. If we want to make a system now to move these up together, I'll need to send a position message to this fizz body, but I'll need to send a position 2 message, right? Because position 2 is the one that change, or is it position 1? No, it's position 2. That changes where this is located, right? We never made a position 2 message. Hold on. Move this over so you have some room. And grab the POC position 1 stuff, duplicate it, make it into a position 2. Right, so now we could, this should be, I believe, 2, right? Yeah, and then we can take this and move it up or down to change where this is. But it's running into the collider object, so it's freaking out. So, what was it at before? It should be at 0. All right, we just need to move up this fizz body. So all we need to do now is take this message, and we also need that to go to a different POC over here for the other one. And we can just take out the word position, right? And then just attach these number boxes to the other POC object and send that to the fizz body. That way, if we change the position of this, they move together. And I guess we actually want to change that in the in the Z scale. There. There. Mine ended up on top, and I don't know why. Let me see. I guess if I just delete the point to point and then undo, it puts it back. And then if we just change it, it should, there we go. If yours is on top, if yours got on top, you can fix it just by deleting this fizz point to point. That'll delete the constraint, then undo that deletion, which puts it back at its default location, and then just change this value to make it update to its current location. Right, so let's go ahead and bake in those position 2 values into here. At position 2, 0 period, I think 4 period, 0 period. And over here on this body, it's not position 2, it's just position, right? At position 0 period, 4 period, 0 period. There. So now when we load those, that will be there. So we moved it a little bit above the floor. Okay. Let me reset my camera again. There we go. Okay, so the next one we want to look at, let me make sure we looked at all the things of point to point. So point to point is pretty much the simplest one. It just joins 2 things together, and there's no constraint as far as how they rotate, whether they run into anything. This, we made a constraint, we made a physical constraint of an obstacle of this thing, so it runs into that backboard. It's not being constrained by its rotation, it's being constrained because it's making a collision, right? There are ways to make it have a maximum range of motion by adding different kinds of constraints. And let's see, don't save changes to your help file. The next one I think we would want to look at would be a hinge. So jit.phys.hinge. I'll give myself some more screen real estate here. Okay, let's open the help file for Hinge real quick. So Hinge will only let you move in one plane, whether that be the X plane, the Y plane, or the Z plane, or some mixture between the 2 of them. Anyway, it's like a hinge, right? So there's the same sort of position 1, position 2 that changes where the thing is attached. There's also rotate X, Y, Z 1 and 2, which change what the rotation of the attachment is, right? So rotate X, Y, Z 2 kind of changes. You can see in the phys draw here that they show you the constraints. There wasn't any on the point to point because there were no constraints. Let me go back to 0 on the, or what is it, 90, 0? There we go. So this circle represents the range of motion. And that means it's a full range of motion, but it's a circle, it's not a sphere or a cone. So you can't go outside of that plane. You can make that circle face whatever way you want, but it can only rotate inside that circle. You can change how much it can rotate inside that circle by changing, so click on up here where it says limits/motors. By putting a limit in degrees, so something like 45 degree, upper limit of 45 degrees, and a lower limit of maybe 0, I don't know. Oh, that you had to hit that button to spawn. I guess it's a different object. Actually, here, let's just do it to the main object. Go back to the main tab and just make a new attrui here on this phys hinge. And go to lower limit. And you right click on the inlet, right, to get this list, and then we can say we need lower limit and upper limit. Upper limit. So if the upper limit is ever less than the lower limit, it automatically just disables limiting. And so then it will be 360. So if you set your upper limit to -1, that will completely disable limiting, which is what it is by default, is -1. So upper limit 45 we said, and lower limit 0. Now you can see that's the slice of pie that you can rotate in. So you can only rotate from here down to there, and it stops, right? So you can make these as, you can have this as a constrained lever that only goes that far. You can use this to make like Rube Goldberg machines, or something tips over, right? You can make sure that all of your little dominoes are actually hinged at the ground, so they always tip over in the right way, you know, like that. You can also, a really cool thing is you can apply modal forces to this. So if you change this motor velocity here to something above 0, it'll start, and then change the strength here to something higher, I guess. Why is it stuck? The strength needs to be greater than 0, and the velocity needs to be greater than 0. I don't know why. I think maybe it's stuck because it's hitting the edge of the. This is just a really bad example in their thing, because it's hitting the side of the world box and then getting stuck. Let's just do it on ours. I'll show you guys that in a minute. Don't save anything in the chink. So we have a hinge now. Let's see. What are we going to hinge? We are going to hinge. We're going to make a clock. So let's make a clock. So we need jit dot. The clock face doesn't need to be a phys body. Let's do a jit dot gl dot grid shape at shape plane. Let's start off with the plane. And then make this at blend enable 1 and at sorry, 1 second. There it is. Blend enable and scale. At scale, let's make it a 3 by 3 feet by, sorry, 3 by 3 by 0. Okay, so there is our grid shape of a plane. So we need to texture this with a clock face. So let's get a clock face. I put one on the website that's that has transparency in it, everything. So if you go to the week 9 page and download this paper airplane, we're going to use that, and download the clock face .png. Make sure you put the clock face in a place where Max knows where it is. Okay, if yours added numbers to it, take those numbers out. Mine only because I had extra copies of this. Make sure whenever you're working with file names in Max, you'll save yourself a lot of hassle if you make sure there's no spaces in your file names. Okay, so download those, and now we can load that in there as a texture. We're going to need to put this. We're going to go. Actually, we can just drag the clock face from the Finder. So wherever you put it, if you drag it on there, it'll turn into a fpic object. Then we can send that into a JIT GL texture object. And we got to give this a name. So let's call it at name clock face. Okay, so patch that in there. You're going to need a bang and send the bang into the clock face, and that should then send the texture into the clock face. And now we just need to apply the texture to the grid shape, and we can do that, I believe, by just attaching it here, but that might not be right. Yeah, that works. So you can just patch that into the grid shape, and now you have a clock face. And it looks circular even though it is square because you have 0 opacity on those corners. Okay? All right, so now we got our clock face, and now we need to attach some hands to the clock face using our JIT Phys Hinge. So let's start by making the hands. We're going to need a JIT.Phys body. And this is going to be the, let's just use a cube at shape, cube. And then we're going to scale it to be long and thin like a clock hand. So at scale, what? 0.1, 1.25, 0.005. At scale 0.1, 1.25, 0.05. There we go. It fell to the ground, and there it is. So let's attach that with our Phys Hinge. There we go. Look at that. It's right in the middle there. Let's move this down below. Wonder what happened to my my punching bag disappeared. What? I don't know what happened to my punching bag. There it is. That fixed it. Okay. So let's move the clock down below the punching bag so that they aren't running into each other, or at least so that the hands don't run into it. So we can just, let's see, to do that, we're going to want to change both the position of the clock face, but also the position of the hinge. Let's see if I can save some time here. So position 0, Phys Hinge is at position 1, is 0 period 1.25 period space negative 0.05. See there? Now that's right on the center point of that clock. We just need to adjust the position 2 along with the position of this grid shape to move the clock down to where we want it. So let's just grab this same code that we used here, the POC position and the POC position 2 stuff, and we can move it down with this. Not the Z, it's the Y. There we go. So it looks like -3 is a good value for that. Let's just bake that in there real quick. Say at position 2, 0 period -3 period 0 period. Okay. Cool. So we got one hand. Let's make a grid shape. You could, let's see. Just try duplicating this here, Phys body, and changing it from a Phys body to a GL grid shape. can't spell today. And attach that to the phys body. And let's give it a color since it's going to be the same color as the clock otherwise. At color, I don't know, blue, 0, 0, 1, 0, 1. There we go. There's a blue minute hand. Okay, now let's make an hour hand. We can just duplicate the minute hand stuff and just adjust it slightly. So duplicate all of this. And we're going to change the where is the other one? Change it to, looks like 0.110. Yeah. So scale here is going to be 0.1. Instead of 1.25, this is going to be 1.0 and then 0.05. So that's there. But now you see they're at the same plane, so they're running into each other, right? So the hour hand can't go past the minute hand without them hitting each other. So we need to move it this way a little bit in the Z scale. So we just have to adjust the position 2, I believe, a little bit. At position 2, 0, negative 2.50. Where is that? At position 2, negative negative 2. That's not right. Oh, we have it in 3, and I just have it different in my notes. Sorry. I'm trying to figure out where it's supposed to be. Well, let's just figure it out. Let's just put it somewhere, and then we'll move it until it works. At position 2, position 1. Okay, so this number needs to be further out, right? So let's try, instead of negative 0.05, let's try negative 0.1. Is that far enough? No. Let's try negative 0.3. There we go. That worked. Okay. How about negative 0.2? Is that going to be better? Negative 0.2 works too. All right, cool. So now they're further out. We need to change the look, but it's not quite attaching right in the center. So one of these other numbers is wrong. Let's see. Sorry, I keep getting lost where I am. There's so many position 2s all over the place. Sorry, it's the position 1 that we're adjusting. Yes, okay. So this needs to be, instead of 1.25, probably wants to be just 1. There we go. Yeah. Okay, so now they're the way they should be. The hour hand is on top, the minute hand is underneath. I don't know if that's the way clocks normally have their hands. Doesn't matter for our purposes. But we have this, now we have this sandbox where we can fling these arms around if we want. Let's make this one, let's change the color of this one. Instead of, let's make it green, I guess. There we go. Cool. Now let's make these clock hands move like a clock would. So we need the minute hand to go 12 times faster than the hour hand. We're not going to actually make it move at clock speed because I don't want to sit here and stare at a clock for a whole minute or an hour. But we'll figure this out. So to make things move, you send the message motor velocity to the Hinge object. So motor velocity $1. And we can send a float value to that. And a positive value seems to go counterclockwise. So we're going to want to give it a negative value, obviously. Okay, and then what do you think? We just need to take this value, right, and divide it by 12 to figure out the speed for the other one. So let's take a divided by 12 and send it into another motor velocity message and pass that into the other hinge. And so now if you set this, the clock will spin like a real clock. Well, except for backwards. So you have to have a negative value apparently. All right, so I don't know what speed you'd have to do to get this to turn at real time, but I bet you guys could figure that out. A clock. All right, cool. Next. So far we've been fixing things to fixed points. Let's attach a couple things together that are only fixed to each other. We're going to make like a little like bendy snake, and it won't be that hard. So let's save screen real estate. Let's make a subpatch. So just P, and let's call this snake. Okay, and inside the snake subpatch, we're going to put some point-to-points and some same capsules and grid shape capsules. Actually, let's see if we can grab the capsule body and grid shape here and the point-to-point. Let's just grab all these. The fizz point-to-point, the fizz body, and the grid shape with the capsule that we used for the punching bag. Copy that and let's put that inside the snake. So you can get back to your snake subpatch by double-clicking on it. Okay, so for now, let's delete this point-to-point and it should fall to the ground. My punching bag keeps disappearing, but I'll deal with that later. Are your guys' punching bags disappearing too? No. Okay. I think it might be because I might have another patch open somewhere and there's conflicts of universes colliding. Okay, let's make this green. Let's be a snake. 0, 1, 0, 1. There we go. It's a green snake. Now, let's see. We just need, let's duplicate this, and we're going to do 1, 2, 3, 4, 5 different segments. So duplicate the fizz body and the capsule 5 times. So now you should have 5 little segments on the ground there. And now we just need to attach those with some point-to-points. Is that the same scale I had? Yes. Good. Cool. Jit.fizz.point-to-point. And let's see. At position 1. So this is to offset the first body's anchor point to 0, period, 0, period, -1. That will put it at the top. And at position 2, 0, period, 0, period, 1, period. So the opposite of that. Attach the first outlet here to the top fizz body. Attach the second outlet to the next fizz body down. And those now, it stops being constrained to a point in the air, and instead they're just constrained to each other, and you can pick them up. See that? And they're hinged to each other. So let's go ahead and let's duplicate this a few more times. Point-to-points. We need 4 of them. And just rinse and repeat. You can attach the constraints to more than one fizz body, or a fizz body can be attached to more than one constraint. So now this becomes the first one of the next point-to-point, and then the next fizz body becomes the second one of that. And so just continue on that pattern. So this becomes the first one of this one that you already patched, and the other one comes the second one. this last one, this becomes the first, and the last one is the second. So now you got a little like green caterpillar that is segmented and jointed. And this, again, there's no constraints on these point-to-points, but the you have a natural constraining system because the fizz bodies collide with each other and don't let it go past that point. This is what's called Ragdoll Physics, where you just have objects that are constrained to each other and they bounce off of each other and they make a natural kinematic system. So you can actually make an entire like Ragdoll avatar and use connect data to move that around. Let me just show you guys a cool patch. Physics patch a day. So jitter physics patch a day. This guy put together a whole bunch of physics patch a day tutorials, and kind of what we did today is similar to what is in here as day 9 does this snake thing. It also has a different version that's a little bit more complicated, but can create an actual smooth snake without segment joints. So look at that. Another cool thing, if you want to get started on creating an entire full ragdoll, look at this day 10. He only does the upper body, upper torso of this, but you get the picture, and you can add constraints to the legs and other parts of this model, or any model that has a rigging system similar to this Lego guy. But the Lego guy is a good one for working with constraints, because there's intrinsic constraints in this Lego, right? You would imagine the legs can only hinge forward and backwards. They can't go out to the side at all, right? So we've looked at hinges. We've looked at point-to-point constraints. I showed you guys this, so feel free to use these. There's some really cool projects in here, really cool physics code. Let's see, what else do we want to do? We want to do a bar slide. And we've done hinges so far. That was the hands here are hinges. So let's do a bar slide. So we can close the snake patch, sub patch. If you want to make it a little bit more obvious that it's there, so that you can remember to look inside of it when you're trying to find things, you can go into the inspector for it and change its background color to green or something. Like that. I don't know. And you can actually change the font size of it, and that'll make it look bigger. So if I made this a 20 font, it'll make the sub patch bigger. Okay, so bar slide. What we're gonna do is we're gonna use the bar slide constraint to make a little paper airplane model look like it's kind of floating across the room. And you could use this kind of model to send objects on rails to particular places or directions. Okay, so JitFizz bar slide. Let's just look at the help file real quick. What are we doing on time? 58. Oh, it's only 2 o'clock. Great. Yeah, we might get out of here early. Bar slide, option, click. So if you move it out of the way so you can see the window and turn it on, you can see you can make this thing slide one way or the other way. This also has constraints. It has a rotation constraint that's turned off right now, but you can make this not rotate all the way around, which is what we're going to do on the paper airplane. We're going to make the paper airplane only be able to rotate like this as it's being thrown forward, right? So it looks like it's kind of rocking in the wind as it goes forward. You can constrain how far it moves forward and backward. If you don't put a value in, it will go until it hits the world box wall. And the same sort of so rotate XYZ 1 and rotate XYZ 2 kind of change the vectoring of, so 1 is how the thing is attached to the slide. 2 would be which way the slide's actually facing, right? So you could create a system. We're going to look at a fixed system to make this airplane glide across the room, but you could easily create a system where you have something that you're launching, you pull it back, you aim it by changing this rotate XYZ2 value to aim it to where you want it to go, and let it go, and it goes there and then hits something or does something, right? So let's look at how we could do that. Fizz bar slide. We're going to need a let's start with a fizz body. jit.fizz.body. And the closest thing primitive that I got to this paper airplane is a cone, at shape cone. And let's give it a scale at send scale 0, so it doesn't pass on its scale, and instead give it its own scale of 1.7 at scale 1.7 3. There's only 2 values on a cone, what its radius is and how tall it is. All right, so there's our kind of tall cone. We need to attach it to the bar slide. Boom. So now it's attached to the bar slide, and I can push it left or right. So that's cool, and I think that's where we're gonna want to do it, just so that it's obvious how things are moving. Let's leave it to going left to right. But we want to change the rotation of this cone on the slide, right? Because right now the cone's facing us, so we want it to face this way. So we need, what was that? I believe that was the rotate XYZ 1. At rotate XYZ 1, and we need it to rotate around the y-axis, so 0, 90, 0, right? Yeah, there we go. So now we have a kind of a cone shape that we can push one way or push the other way. And let's go ahead and attach our paper airplane to this. Jit gl.model. And did you guys download the paperairplane.dae from the website? And make sure you put that in one of your Macs directories at file paper. I believe it's just paper airplane. Oh, capital P, paper, capital A airplane. .dae. There it is. Okay, we can do at lighting enable on this as well. At lighting enable 1. At smooth shading 1. That'll make it look a little better. And go ahead and attach that to the fizz body, and there it is. Oh, let's scale this independently. We can make it bigger. Let's just make it 2. Scale 222. At scale 222. There we go. So now we have a paper airplane we can throw across the room from one side to the other, but it'll rotate all the way around. We're going to constrain it to not rotate all the way around. We should also move it up because it's running into our clock hands. So to move it up, I believe that would be what? Position 1 or position 2? Position 2. Good guess. Good guess. 50-50 shot. Yes. All right. Position 2, what? 0, probably a what? Point, no, 2. Let's try 2. 0. Yeah, that looks right. Actually, let's put it above the punching bag, right? My punching bag is missing, but yours isn't probably. So move it above the punching bag. So position probably what? 6? 7? Yeah, 7 looks good on mine. There we go. Now it's above the punching bag. Okay, so now we just need to constrain this. How do I do that? I forgot. Open up the help file. It limits motors. Lower limit underscore linear. So that's, oh, but that's linear. We don't want to constrain it linearly. We want to constrain it, why don't they have that? Angular. They just didn't show it, but it's we need upper limit and lower limit angular. So at upper limit angular, I believe I put it as 9. I think I went from 90 to 90. Let me take a look. Yes, 90 to negative 90. So upper limit is the higher number, and the lower limit's the lower number. So at lower limit angular, negative 90. And now it'll only rotate from there to the other way, to there. It'll only rotate 90 degrees on either direction. So then, now all we want to do is actually lower it down just a bit so that it has a center of gravity that wants to self-stabilize it in the center, because that's the way an airplane would kind of fly. So that is, I believe, position 1. We want to change the attachment point. So that's a position 1. Yeah, at 0.50. At position 1, 0, and then we're going to offset it by 0.5 in the Y. And now it hangs down below the bar slide, but is still angularly constrained to it, right? And so now you can throw this across the room, and it will maintain its like rotation. If you give it a little flick, it'll kind of rotate and kind of wobble as it goes across the room. So now let's make a system that allows you to like pull it back like a rubber band and let it go, and it flies forward. We can give it, what was it? Motor velocity linear. So this, you could both have it, you can give it 2 different motors on this. You can make it spin this way, or you can make it push forward and back. Motor velocity linear, if I drag this out like this, maybe, you'll be able to see it. There we go. So if we change that value, why is it not moving? There it goes. I don't know why it wasn't wanting to move. So something like -3 makes it want to go that way. But it's too strong to fight our fizz picker. Our fizz picker can't beat the motor, so we need to change the motor strength. So let's give it a value here. Let's bake this motor velocity in there first. At motor velocity, not angular, linear. A motor velocity underscore lin. What did I do before? I think we just did it. Oh, 0.1. No, -2. Sorry. -2. Now it will always want to fly that way, but we just need to lower the strength of this now. If you change this to strength and made this a 0.1, you'll be able to grab it with your mouse. At least I think so. At motor strength linear. Oh, that's strength and not motor strength. That's what it is. At motor strength linear. 0.1. Yeah. Now you can grab it. There we go. And let it go, and it see how it glides itself across the room? Right? And I can change, if I wanted it to go faster, I could change this motor velocity linear value to something higher, or something lower, rather. Now it goes faster, right? So you could create a system that basically took the position, took an anchor point position, took the position that it is when you the position that it's in when you let go of your mouse, calculate that as a velocity that you send to the motor velocity linear, and so the more you pull it back, the faster it goes, and that would kind of create an elastic type of behavior. And then you could also have a system that maybe changes this rotate XYZ 2 value to change where this bar slide is facing. So you can use that to create a system to launch something. Okay, 2:10. We got out of here a little bit early. Okay, there's one other thing I can show you it was stuff we didn't get to last week, so we can just copy it from the web page. I just want to show you this. I did mention it in the email I sent to you guys. If you go to week 8 and you download this patch, the collisions and the collision ball, and get this Union Square skybox, one cool thing I wanted to show you is that you can actually reflect the skybox in the reflections of your physics objects, which adds a lot of realism. I think it's something kind of weird with the circular ones where I can't really get it, the camera view. It seems to always be reflecting something over there. So that's a little funky, but the squares work the way they should. So that's really cool, and you can have it reflect. It'll only reflect what is passed into this fifth input, 1, 2, 3, 4, fifth input, that's environment as a texture or a matrix. So you could patch video into that and they would reflect the video. You could, it's possible, if you wanted to reflect everything in the scene, it would be really difficult. It would be really taxing for your computer to do, but it would be possible. You can actually get an output of the render as a matrix with a JIT-GL async read, and patch that in there. If that's something you guys are interested in, I can show you. But let's copy this stuff from this collisions patch and put it into our sandbox patch real quick. So just grab the cube map, skybox, and material stuff, and then you can close this patch. I'm not going to save any changes, and I can paste it into this patch. Where did it go? Come on, where did it go? Am I crazy? Is it not did I not copy it? Oh, it was unlocked. It was locked. There we go. Can't paste something in there when it's locked. I always forget that because I don't lock things very often. And then you'll have to hit this thing to get that started again. So this is a skybox of Union Square. My camera's dead. Hold on. There we go. Oh, my caps lock is on. That's why it stopped listening to me. And let me see if I can redo my... there we go. All right, fix my punching bag. All right, so say I wanted the punching bag to be made out of glass and reflect the stuff around me. All I'd have to do is, see how I gave the material a name here? So we have the JIT-GL cube map, which is loading the file, skybox file. We're sending that into JIT-GL skybox that creates the actual geometry to make it go all the way around you. And then we pass that into the environments on JIT-GL material, and we give that material an actual name. In this, I called it balls. because in the last thing there was a bunch of balls that we were attaching it to. So all I have to do now is apply that material to this grid shape over here, the capsule, and I can either attach them with a line, or better yet, I can just specify at material, click it out of the list, balls, and now it has that material. It'll maintain its color, and it'll colorize the material until the material changes. As soon as the material changes, it'll overwrite any color information on the ball. But now it's kind of looks like a Christmas ball hanging down below thing. Cool. Any other questions? All right. So I can stay till 3 o'clock if anybody needs me. If not, we can wrap it up early and everybody can have a great spring break. Let's see. For homework, I would like you to basically do something that has, I don't really care what it is. Just have a patch where you play around with a couple different constraints. Have at least 2 different kinds of constraints in your patch, and have at least one constraint be attached to nothing, like this is, where it's just constrained and attached to a fixed point, and at least one constraint that where multiple things are attached, like this, like the snake here, where they're attached to each other. What would be great is if you could then now incorporate this constraints with collisions to trigger something. Okay, so 2 different types of at least 2 objects, probably actually more like at least 4 objects, right? At least 2 different types of constraints, at least one constraint that's fixed and one that is attached, and at least one that's attached to just another body like this, and then incorporate collisions into your patch to do something. Okay, and the other thing that will be due after spring break, I need to know what you guys want to do for your final. This will be your round 1 pitch to me. So basically, send me an email with what you, a paragraph describing what you want to do in Max, and then we'll go from there. If it sounds like you're hitting all the areas I need you to hit, I'll say great. If not, I'll say that's cool, let's do that, and let's see if we can add A, B, and C, right? So that's the only requirement, is that I approve your patch. Most people get to do pretty much exactly what they want to do. So those are the 2 things that are due by a week from Wednesday when we get back from spring break. All right, thanks everybody.